screen like? No, okay. Okay, so can everybody hear me? Yeah, okay. So we're going to start in a few minutes. So this lecture is about algorithms and C++ data structures. Let me edit the stream title real quick. Lecture, algorithms and containers. Okay. Is everyone ready? Yeah, we won't be covering SCD rotate for now, actually, because it's one of the less used algorithms, but we'll be covering these. So I hope that'll be enough to satisfy your needs. Right. How about we get going? Okay, so I wanted to start with containers, right? These are our containers. We'll start with std vector, right? But there is a lot of different containers in C++, right? There's more than these, and some of these are not considered a container, but they're still used, right? As one. So we have std vector, right? Which in this case will store integers, right? So we have a vector of integers, and we say, okay, well, you have the values 1, 2, 3, 4, 5, right? So now if we go for autoconst reference each in x, which doesn't have to be a reference, but, right, we'll see that MSVC, hello? Oh god, it's crashing. Right, I hate Windows. Right, basically it just contains this data on the heap sequentially, right? So they're laid out next to each other, 1, 2, 3, 4, 5, right next to each other. So if you get a pointer to this one, right, and you +1, then you get the address of this one, right? Which is why copying a vector is very expensive, right? Because if you need to copy a vector, resizing a vector is therefore very expensive because you cannot just add an element to the end, right? You have to relocate the entire container, whereas an std list, for example, could just add an element without any reason. Okay, so that is an std vector. It's a sequential chunk of memory, which is way faster than std list, right? But we'll get to that in a bit. Okay, so that was std vector. Std string is seen as a specialization of std vector, right? It's almost the same as std vector char, right? But instead it's std string, right? And why is that done? Well, std string has its own type because it has short string optimization, right? So when your string is shorter than 15 characters, it gets put on a stack. Otherwise, it gets put on a heap in a vector, literally. Like the internal container could be a vector for that. That's no issue. So it is an std vector, but with more member functions. That's all. Let me zoom in a bit. Right. Okay, so that are these two. std list, right? We mentioned std vector before, and how it's a sequential chunk of memory, right? So 1, 2, 3, 4, 5, right? In the same way std list exists. Right, but it's not sequential. So std list is a linked list, right? So what happens is, okay, I have my first element here on the heap, right? And my second element is here, and my third element is here, and my fourth element is here, and my fifth one is here. And what happens is that this one says, okay, the next element is this one, and then the next element is this one, and then the next element is this one, and then the next element is this one. And this is a very expensive container to go over, right? So if I do to iterate over for auto each in X, doing this is much cheaper than doing this, right? And that's because operations in memory, their memory isn't sequential though. Lists are a sequence, yes, but their memory is not sequential. So it's not next to, yeah, right. So it's not contiguous. Sorry, I used the wrong term there. So that's the reason why std vector is practically always used over std vector, right? Because over std list, it's because std vector's memory is sequential, so there can be many more optimizations from a CPU point of view, right? So your vector can be put into L3 cache, right? Whereas a list could never, because the memory just isn't close enough to each other to be able to be cached, right? So a list, right? So you have xd list, right? I say y.begin. Right, so you have y.begin, right? You have y.begin, which if I increment it basically, which in this case is not possible like that, right? So auto begin is, right? So, right? This one points to 2, right? But it's not guaranteed that this pointer is literally just 4 bytes later than this pointer, right? So size of int is 4, but it's not guaranteed that this is 4 bytes earlier than this one. And that's why std vector is much faster, right? The only purpose where you could use std list is if you have a lot of random insertions and removing operations where your contain type, in this case int, is not movable, right? So if I have this std string, but it's some stupid specialization where my string is not movable, right? That's when you would use an std list, right? Because copying that string over to is much more expensive in an std vector than an std list. Okay, so that was std list. Then you have std forward list. So remember how I said how this was std list? Well, I kind of lied. This is std forward list, right? std list also has pointers back to the previous one. So you can have reversed iterators. So you can go to the next one, but you can also go to the previous one. Well, with std forward list, as the name indicates, you can only go forward. So that's the difference between std list and std forward list. There is no such thing as reverse iterators. Okay, so these 4 are on the heap, right? Then we have one that's on the stack, right? So we have a pair that contains both an int and an std string, and I say x is 5, hello, right? And now I can std cout x dot first, x dot second. I hate Visual Studio, right? And I hope this is gonna run because it didn't before. Yeah, okay, Visual Studio's debugger is messing some stuff up. My apologies for that. It did print it, actually. Okay, so an std pair is just here. Right, so an std pair is just 2 blocks of memory right next to each other, where this is my int and this is my string. Right? That's what std pair is. Now, std tuple is very closely related to it, except it has more elements, right? So I can say, okay, well, this std tuple contains an int, a string, bool, uin30, 64 underscore t, right? And I can say, okay, well, 0, high, true, 5, right? Right, so this is a tuple, and then to extract an element from it, you can either std get 0 tup, which this is a int, right? But I can also say, okay, get me the std string, and then it gets a reference to this one, because this one gets converted first, right? Okay, that's std tuple. It's std pair, but it has more elements, basically. Okay, now we get to the cool stuff, right? So we have std in order map. We map an int to an std string, right? Let's do it the other way around. So we map a string to an int. include this, right? And we say, okay, well, the string hello is now equal to 5. And then if we want to look up hello, this evaluates to 5, right? I can print this again, but I feel like MSVC is going to be weird. I'll just let this run here while Okay, that's why it was stalling, right? Okay, so it gets value 5 for hello, right? What are the disadvantages of ordered map versus unordered? Right, we'll get into that in a second. It's the next one. Right, so you have SCD unordered map, right, which has an O1 lookup time, it means that if it average case scenario, it has an O1 lookup time, so it only needs to check one element to be able to find this value 5, right? Let me close that. So it only needs to do one check to find that value 5, whereas the next container that we're going to talk about is SCD map, right? Let me keep this here as well. So the way they work is, the way they're used is exactly the same. Okay. SCD string to int, we say, okay, we call this one y, and we say, okay, well, y, hello, you're now equal to 5, and then we can see out y, hello, right? So it literally just looks up this value. But the difference between the two is that SCD map does it in a different way, right? Do you know what a red-black binary tree is? Let me pull up an image. Right. So the SCD map is ordered, right? So what happens is that instead of oh my god. Right. So this is a hash map, right? The thing, which is an unordered map. So the thing it does is that it hashes the key, right? It gets some integer value from this string, right? And it says, okay, that is the index that my element is at, which requires one lookup, but possibly has an expensive hash, right? So if your type is not hashable in any way, shape, or form, like you cannot guarantee that it's unique, then you go with an SCD map, right? Because an SCD map is, it's ordered, right? So average case, it's an O n log n lookup time, if I recall correctly, O log n lookup time, right? So it'll start here, and then it'll be like, okay, is my value 13? No. Okay, it's smaller or bigger? And then if it goes to larger, then it goes to 17. Okay, and then it continues until it finds it, right? And that's how an SCD map does its lookups. Whereas an SCD unordered map just does an O1 lookup for the hashed key, right? So say hello hashes to value 15, right? Yeah, I think it is O log n. Not entirely sure, but looks with buckets. Yeah, it does. But that's something that doesn't really matter. Well, no, it doesn't go to the next bucket. So Alex in chat is saying, okay, well, SCD unordered maps looks with buckets, right? And what a bucket is an SCD list, SCD forward list, actually. So what happens is it checks for the hash, right? And if that hash value is 15 and there's multiple elements with the hash value 15, then it goes through every element in that sequence of the ones where the value is 15. And then if it finds it, it returns it, basically. It doesn't go to a different bucket. If it's not in that bucket, it doesn't exist. No, ordered maps, so SCD map is based off red-black tree, while an unordered map is a sequence of linked lists, basically, yes, where every linked list ideally has only one element. Okay, right, and that's where the extreme speed comes from, because it only needs to do one check, right? So we had these two. And then an unordered set is essentially the same thing, except it doesn't have a value bound to the key, right? It's literally the concept of a mathematical set. Because it's not relevant. Yeah, there is one of these two that causes more CAS mishes because it's not really relevant. Like, yeah. So, okay, SCD unordered set. right? There's multi-map as well, but well, we won't cover that here because it's not used that often. Okay, so we say, okay, well, this set has values 5, 5, 6, 7, 8, right? But as we mentioned, a set is a mathematical concept of a set, right? So it can only have one 5, right? So if I now print every element in this const each and x, there, right? 5, 6, 7, 8. Because the whole point of this set is that every element is unique. So no two elements can be the same, right? And then you have std set as well, which is exactly the same, except it does its lookups in a different way, right? It's the same difference as std map versus std unordered map. Okay, that were these. std optional. Yes, it does automatically remove the 5 because the whole point of it is that every element is guaranteed to be unique, right? If I have a database of student numbers, right, and I extract the student numbers from the database, then you would store that in a set because they're guaranteed to be unique. You don't want the same student to occur twice, right? It's a very basic example. Okay. Okay. Let's start with removing all the headers. Include optional, right? So optional has a helper type. It's not just std optional int x, right? Let me set my project to 17. Where do you do this? I think here. Right, so std optional was introduced in C++ 17. That was why it was throwing an error before, right? And the point of an optional is that it either has a value or it does not, as the name says. So I have an optional integer, right? And std cout x dot is underscore none has value. Sorry, I'm getting used to Rust. Right? And this one does not have a value. But now I say, okay, well, x is 5, and then does x have a value? And if so, that value is right? So initially x does not have a value. Then I say, okay, well, assign it the value 5, and then it does have a value, and that value is 5, right? And the thing with std optional is that it has some great utility function. So okay, I say, okay, y is 5. I say, okay, well, x, you're now empty again, right? So x, you're std nullopt, right? So you're empty. And then I can say, okay, x has value, but if it does not have a value, I would like that value, right? So it's going to give me this value 5, right? Let me run it. Right? It does not have a value, however, it gets me that 5. So it's very useful for using it for a function where you either get a response from something or you do not, right? It basically requires you to handle the error, right? And you're right in chat. I think I told you yesterday that std optional size is twice the contained value. I have no idea why, right? We can actually find that out right now. This is the MSVC standard library. Yeah, let's don't. Okay. I have no clue why it takes up twice the size, but it does. So be cautious with it, right? So you could see an int pointer, right? You could see this as std optional int, right? But this is twice the size as the raw pointer. So be cautious with that. If you suddenly get a memory spike, that's your reason why. Okay, std dequeue. std dequeue is literally just a queue. So include dequeue. std dequeue. A dequeue of integers. I say x is a queue of 1, 2, 3, 4, 5, and you can either push to the end or push to the front or pull an element from the front or pull one from the back, right? So I say, okay, well, x.pop underscore front, and then suddenly my values are 2, 3, 4, 5, right? I can say s.pop back, right? Or s.push front 7, x.push back 9, right? And then my sequence is literally just 7, 2, 3, 4, 9, right? So it's a queue. So you push elements and then you pop the first one. I forgot to have one here. It's STD stack. STD stack is very similar to it. However, it functions in a different way. It functions under the first in, first out, right? Last in, first out. Yeah, my bad. Queue is first in, first out. STD stack int. All right, and the same my stack has 1, 2, 3, 4, and I can I can x.pop, right? Whatever. I don't use STD stack, right? Push 1, x.push 2, and then this here 2 gets popped, and then if I pop again, 1 gets popped, right? And now it's an empty stack again. This is literally just the way your memory as a stack works as well. Are all the containers clear? Because we're going to move on to algorithms. No, the video will be uploaded later. You can check it back yourself. The YouTube link is in the channel. Well, no, that wouldn't work for STD optional. Are you sure? So somebody's saying this is STD optional storage. Right, but this is the efficient storage. This is the. Yeah, right. It's an implementation, right? The STD lib one uses twice the memory, right, for STD optional. So somebody linked this one, right, and it's a union of char and value, right? But this is not how it's implemented in GCC, for example, because GCC uses twice the memory. Okay, so those were the algorithms, right? For all the so those were the containers. I mean, okay, so for all the algorithms, we'll be using this STD vector, 1, 2, 3, 4, 5, right? This is all we need. Plus our beautiful IO stream header. Okay, so STD find, right? We want to find where the value 4 is located, right? So we'll get this, right? This should print the value 4. So it finds the pointer to 4 and then gives us the value, right? All of these algorithms, the ones that find or give you anything, if they cannot find the value, it returns your second iterator. So it returns this element. That's how you can check whether you find it, right? So if std find x.begin, x.end, 6, 7 equals x.end, right? Right? It should print not found. Right? Not found. Right? So if it's equal to the end of your container, to the end of what you passed, then it is not found. That counts for all of them, right? Okay, so that's std find. Std find just gets you a pointer to the value that you passed. Result is std find if, right? Std find if is a bit special because it takes a function. So we have x.begin, x.end, and then we have a unary predicate, which is auto element. So every element in this container will be passed to this function, right? No, because end is right past the end, right? So you have the amount of elements, right? End is 1 past it. It's specifically used for that purpose of being able to iterate until you had all the elements. Right? I can dereference end, but that's undefined behavior because I do not own this memory in theory. In practice, you probably do because of the way memory works. But. Right. So now we say, okay, we want to find the first element that is a multiple of 3. So return elem modulo, right? We can, oh, fuck. No, I will not recap the lecture because we've been going for almost 25 minutes now. The video will be uploaded to YouTube later. You can still tune in for the algorithms right now, which we just started. Okay, so this will get us the value 3, right? So we can say, okay, stdc out, result. 3, right? It found the first one that's a multiple of 3. That's std find if. So if this function returns true, it gets you that element. Okay, next one. std reverse, right? Simple. It does what it says. Begin, x.end, comma, done. And now if we inspect... Oh, shit. How do you place a breakpoint in MSVC? Breakpoint, insert breakpoint, sure. Yeah, I'll explain what a lambda is in a second, right? So step over by 1, right? And now we can see our vector has size 5, and it's in order 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5, right? So what I used before, n comma auto const lm, right? This syntax is a bit funky, but it's basically just a function that doesn't have a name. That's all it is, right? In this case, because this is empty, it's just a function that doesn't have a name. Just imagine that it's a function. That's all it is really, in this case. Right. We had std reverse, std copy. Okay, so we say, okay, we have another vector, which is int, which is called y, and we say, okay, y dot reserve space for 5 elements, right? And then we say, okay, std copy from x dot begin to x dot end, and I want to copy it into y dot begin, right? And then we'll breakpoint right here. How do you place a breakpoint? Fine. Right? Let's wait for it to run. That's not good. Yeah, I just briefly explained what lambdas are. Okay, well, Visual Studio is being they stop your code, so you can the breakpoints inspect your code, stop your code, so you can inspect every variable and stuff. Wow, this is really crashing. Okay. Okay, well, oh, please don't close it now. Okay, fine. That worked for some reason. Yeah, this is why I don't use Windows or Visual Studio or whatever. Okay, so all this does is make y equal to x in this case, right? Keep in mind you can always copy less. So if I do x minus 2, then we get just 1, 2, 3 in the y container. It's all dependent on your last iterator where it stops. Okay, std move. Okay, so probably do this then. Hi to 3, 4, 5. Okay, so we previously covered move semantics, right? Right, we previously covered move semantics. It was covered by, I think, Lapinos. So if you don't know about move semantics, then ignore this single algorithm, right? Yes, yeah, okay. You got it. Okay, so std move is the same thing as std copy, except it moves every element, right? So it doesn't copy them. So x.begin, x.end, comma, y.begin. So it just moves everything over from this container to this. So this now owns every element in this one, right? Not extremely useful in this specific scenario, but it's useful when implementing your own containers. Okay. std sort, self-explanatory. However, I will demonstrate it. Int 3251/8, right? I want to std sort x dot begin comma x dot end. Yes. Oh, can we not crash this time, please? I forgot that I shouldn't. Okay. So now you can see x is sorted 1, 2, 3, 5, 8, right? And you can pass your own function at the end again. That's your comparator function. Read up on CPP reference. This lecture just serves to tell you everything real quick. SCD is sorted. Self-explanatory. It's an O-N operation. Right? Sort works for anything that has the less than defined. So if your object has operator less than defined, you can use std sort. And even if not, you can pass your own function to it. Right? So I could make my own real quick. Right? So now this is example. Oh my God. Right? So now these implicitly converted. Std sort x dot begin comma x dot end. Right? And you'll see, okay, this is going to error. Right? It says, okay, well, could not apply this stuff, right? Could not apply less than to this value, right? So what you then do is you pass this auto first, auto second, right? First is less than second. Oh, this is not Rust again. The difference between cout and printf is that cout is C++ and printf is C. Printf is unsafe. Okay, and this will sort it in the exact same way. Okay, that's that. std is sorted. 1 if it's sorted, false if it's not sorted. Self-explanatory. O-N operation. std all of. This is for anybody that has done Python or whatever before. Basically, it returns true if every element in a sequence are true. So I'm looking up the documentation real quick. Yeah, okay, it takes a function. Right, so if every element is true, then this is true. If not every element is true, then it's false. And a company, you have std none of. If all the elements are false, it's true. If std any of the elements is true, this will be true. So this one will be true. Right? Okay, now we get to a slightly more complicated one. Okay, so I want to remove every false value, right? So x.begin, comma, x.end, comma, false. So I want to remove everything that's false. So let's breakpoint here again, right? And we say, okay. And what remove does is it just moves it to the end. So it says, okay, well, you're at the end now, right? So you can see, okay, x is now true, true. What? Yo, what? Okay, that's funky. So we can check the documentation ourselves. Yeah, of course. Wait, so what does? So what does std remove do? Okay, so what std remove does is it says, okay, well, your new end is like right here. I actually don't know. Huh. Okay. Right, but then why does it change to true? It compares them by letters. So if the first one starts with an A, then it's smaller than if the first one starts with a B. Okay, I'm going to assume this is something that MSVC does. If you use a competent compiler, it won't do this. But essentially, std remove is done by shifting the elements in a way such that... okay. Read up on it, because that's funky. I was thinking about std arrays, right? Okay, so now I have an int array. 5, right? It's unspecified what it does apparently. That's weird. It shouldn't alter my container, but okay. I say okay. So I want std begin, std fill. So I want to fill my container with elements, right? And from the begin to the end, I want to fill them with zeros. We run it, and now they're all zeros, right? That's std fill. It's the modern variant of memset, basically. Okay, so std transform. We're going to need 2 containers again. And we say, okay, why don't reserve 5, right? And now we transform the first container, x.begin, comma, x.end, comma, y.begin. So for every element between x.begin and x.y, put it in y.begin, but apply an operation. Right, so we say, okay, return element times 2. So now everything is doubled. So it should be 0, 2, 4, 9, 8. 6, 8. My bad. My brain is kind of fried. Oh, not this again. Oh my god. Dude, what is this what is this editor, dude? Okay, come on. Okay. I was about to switch to Paint for typing. Let's run it again. Whatever, it's not gonna work. Every element gets doubled, basically, because of this, and it gets put in Y, right? And you could do it in place. You can say, okay, well, put it in x.begin, right? So now x has been modified, so you don't even need this. I really hope this stops. I'm sorry for that. I'll just stop running the debugger. I'm not sure why it does that. Okay, std film, std transform, std swap. Okay, std swap's easy. We say std swap x2 and x3. Now the sequence has swapped these. So it's 0, 1, 3, 2, 4. Okay, that's all self-explanatory. Std max, so I want to get the max value between x0 and x3, right? This will return 3, because that's the maximum value. So it literally gets the maximum of 2. Now I want to get the maximum of a range. X.begin, comma, x.end, right? I want to get the maximum value in this range. This will get me 4. Say there is no elements in this range, then this value will get returned. Okay. In the similar fashion, we have std min. So we have std min between 2 and 4. This will give me this value. Okay. The same thing we have for std max element. We have std min element, which is a range again, x.begin, comma, x.end. In a similar fashion, again, it returns the end iterator if your container is empty, right? This gives you a pointer to 0. This evaluates to 0. Because the lowest value that we have is 0. Now it evaluates to 1. Okay. I'm going really fast, by the way. If anybody has any questions, ask them. Do I have a suggestion for Visual Studio? Yeah, quit your business. drop your operating system and don't make anything new from now on. Okay, std clamp. So we have int x is 5, int max is 700, int min is 30. We want to clamp x between min and max. So we say std clamp our value, then the minimal, then the max, right? So we say y min max. Y is now 30. If I make this 800, y is now 700. If I make this 250, y stays 250. It literally clamps this between these two ranges. Std accumulate. Std accumulate is a really cool one. It's known as sum in Python, right? I think it's exactly the same in JavaScript. But int result is std accumulate from x.begin to x.end, starting at value 0. This is now 7, 9, 10, right? It's total to 10. Int result is 10. It just sums everything up. You can pass a predicate as well, I think. Yeah, you can pass a predicate as well. Okay, we'll go back to std clamp. Okay, we say int value is 50, int minimal is 70, int maximal is 500, maximum is 500, std clamp value 7 min comma max. Now value is 70 because it cannot be outside of the range of 70 and 500. So you literally clamp it between a range. If it's outside of the bounds, it limits it to within the range. Very useful if you need your values to be positive or between 0 to 100 or whatever, right? Okay, std binary search. I should have covered this one before. This one should have been right there. Std binary search is a binary search. It's only works on sorted containers, right? So it will not work with this container. If I now say, okay, std find x.begin comma, oh shit, x.end comma, find me the value 2, it might work, it might not, depends on the implementation of the algorithm, but now it might work, now it might not. We don't know how the pivoting works internally, but only use it on sorted containers, because what happens with the binary search is that it searches by binary value, right? So it starts in the middle, right? It says, okay, is my search for value 2? No. Okay, is it less? It goes to these two. It compares it to one of these two, and then otherwise it grabs the other one. Is it more? Then it does the same thing on this side. That is what std binary search does. Okay, I would actually like to cover std rotate then as well, because we have some time left. Okay, so std rotate. Why is there? Okay, how does rotate work? Okay, let's see. I've never used this one before. Std rotate. I just looked at the reference before you. Performs a left rotation on a range of elements. The new first. So why is this parameter called? Yo, this is MSV shit again. Why is this called mid? Okay, so we place it from x.begin to x.end. The new begin. Right, so now it shifts everything 1 to the left. So it should be 1, 2, 3, 4 now. And I don't know what the last value is, so. Oh god, I pressed compile again. Fuck. Oh god. Dude, this is so funky though. Like, funny, because it does. Can I? Oh wait, let me just get the path to it. I can probably run it myself. C users repos containers algorithms debug. Ah, okay. I made a mistake. I don't know what rotate does, but it should be something like this. Don't take my word for it. Right, it just rotates everything. Yeah, well, it shouldn't crash if my program throws an exception. But wait, no, these are debug statements. Why do they even exist? I don't do any bounds checking. Okay, well, essentially that was the majority of algorithms and containers in C++. Std remove you should read up on, and I will definitely do that too. That was it. Are there any last questions? Oh wait, I should cover std for each. 1, 2, 3, 4, 5. std for underscore each x dot begin comma x dot end. I want to print every element. std cout x, right? Each auto const each. It just goes over every element in the sequence. Right, 1, 2, 3, 4, 5. It prints them all. That's it. Opinions on std for each versus range-based for loops. This is useful for algorithms. Range-based for loops, if you need more code than just one line, I would go with a range-based for loop. Like I do this a lot, right? std for each. I don't know why. I think it's cool. But yeah, are the things we were talking about arrays? Which things? Vectors? Oh, we didn't cover std array. Okay, let's cover std array. Int comma 5 x right 1 goes to 5. Right. So what this is basically okay. You have n amount of elements with this type, and they're on the stack. They're super fast. You don't need allocation for it. Plus, they're really cache performant. Arrays are on the stack, cannot be resized. Vectors are on the heap, and they can and do usually get resized. If you know the size of your data, like the amount of elements of your data, at the time you write your code, use an array. Otherwise, use a vector. That's the difference between an array and a vector, right? Because I can't say x dot pushback, right? I just can't. That's the difference. Okay, that was our lecture. Yeah, it's std reference wrapper is kind of a container. It's a container for a pointer. So I say, okay, well, you contain an int, and I say, okay, you're a new int. And now you're a reference to this value, right? But it's non-owning, right? So you can't do that. So I say int x is 5, and I say, okay, well, you're just a reference to x now. That might be easier, right? You would never have an array of one element, but a container of reference wrappers. Okay, so std vector, std reference wrapper x. I'm gonna use std vector because we just said it was faster. Right, 5 elements. Right, it has 5 elements. X dot begin comma right. Now this is a reference. Every element is a reference to the first one. Right. So we for auto const reference each in x, std cout each Of course. Right? Whatever. It's something like this. I never use. Yeah, you could just do that as well. I don't use reference wrappers. Of course. That's why. No, it's not. Dude, these errors are so cryptic. I don't use MSVC usually. But yeah, this is basically what it looks like. Something like this. Is it pointer 2 or something? Yeah, it's very funky. No, it's not. Okay, whatever. Something like this. That's where I kind of wanted to conclude it. So a reference wrapper is just a reference to another element. In reality, it's internally it's just a pointer, but every references, as we explained in a previous lecture. Oh, std ref. Oh my god, are you kidding me? Oh yeah, because std ref constructs a reference wrapper. No, it does not. Is it not copyable? Yeah, right? Like, that's funky. Dude, I don't like MSVC. Why am I using MSVC? No, because this is just an integer. It's just an int reference. And a reference wrapper should internally convert from an int reference. Right? But it doesn't. I blame it on MSVC. My programming is impeccable, cannot be flawed. I might be wrong, actually. Okay, that was the lecture. Thank you all for dropping by. We'll upload this lecture to YouTube. Alright, good day, boys.